Okay. Let's make sure the closed captioning is working. All right. So we're going to continue on. Our last unit was right triangle trig, and now we're going to start pushing that into its applications in physics. Once we start to get into physics, we start to use the word vector to start talking about triangles. Now, vectors are triangles, but they're not the part of a triangle you're kind of used to. Basically, a vector, in most regards, is the hypotenuse and the angle. Other word, the official definition is a magnitude and a direction. So let me just look at this polar coordinate grid right here. And starting at 0, let's say I wanted to go 842 miles per hour at 74 degrees. So I've got a magnitude. That's the actual number I have, 842 miles per hour. But I also know the direction that it's in. So this right here is the hypotenuse. And this right here is the angle. So they are giving me the parts of a triangle, is what they're really doing. So right here on the polar coordinate thing, 74 degrees is right about here. And so starting at the origin, that's 842 miles per hour in pH, and that is 74 degrees. Okay. Now to finish off this triangle, what you would do is you would do what we call drop a vertical. So I'm just going to drop a vertical line straight down and then connect. Okay. Or up, if you were down here, you would drop it upwards. Okay. So this is now my triangle. And what I would be asked to find in physics is I would be asked to find the y and the x. Okay. So we're going to call the other two sides of the triangle, we're not calling them adjacent and opposite anymore. We are calling them y and x. That's what we're calling them. And right here is my perfect corner. And so that is how you can turn any vector into a triangle. Now keep in mind, notice how this wheel, these angles, always start at 0 and move around. Okay. I also want to tell you guys what they are in cardinal directions. This is east. This is north. At least for purposes of our stuff. 45 degrees is northeast. 180 is west. So this is northwest. 270 is south. So 225 is southwest, and 315 is southeast. Okay. So when someone says I'm traveling north, I am going 90 degrees. Okay. Any questions? Now, this is where we start to get into the point of drawing a picture is extremely important when working physics. That is your first step. Always draw a picture so that you know what your triangle looks like. You've converted your information into triangles. Okay, so we're right here. Now, typically we don't have the big polar coordinate thing. We're just making a quick graph. So what I'm going to do here is I'm just going to do this right here. Boom. Just make a quick little grid, and that is 0, 90, 180, and 270. Okay, so this right here is going to be 40 degrees, so that's somewhere right in here in the first quadrant. So I'm just going to start at the origin, and I'm going to do 40 degrees. And that is 19 feet per second. And then if I wanted to, I'm not being asked to do that, but if I wanted to, I could drop a vertical and finish off this triangle. So that would be my y component and my x component. And now I've converted that into a triangle. Okay. Now, let's look at this one right here. This one's going to be more confusing. To get the right color, purple. There we go. Okay, so this one's given us our cardinal direction. So that's north, west. So northwest is this way. And that is 50 newtons. Okay, so I'm going to start from the origin. And I'm going towards the northwest. That way. For 50 newtons of force. Now my angle, notice how with a vector, the angle is not always inside the triangle. The angle is always measured from 0. So that is 135 degrees of rotation. I've rotated 135 degrees and then applied a 50 Newton force. Okay. And so now I can finish off this triangle. Drop my vertical. And I've got my X and my Y. Boom. There we go. Now notice that I still do not know any of the angles inside my triangle. That's where things get to be a little tricky. All right, so you do want to be careful about that. That 135 is not actually an angle inside of that triangle. That's where triangle math and vectors do have a little bit of a disconnection. So you do want to be careful about that. All right, so let's talk about finding some of those parts. Now this is a nice little shortcut that always works with vectors. And what I mean by a vector is that's where you start at the origin and go out. Okay, so as long as you always start at the origin, right here, start at the origin. This is here for a reason. Okay, this is trying to let you know that starts at the origin and goes out. As long as you start at the origin and go out, the x direction is always the magnitude, which is the hypotenuse times cosine of the angle, and the y direction, the height, is always the magnitude times sine. And we sometimes abbreviate them or symbolize them by putting it in a little subscript position. So this would be the velocity x direction, the x direction of the velocity, the y direction of the velocity. So let's say I didn't have velocity. Let's say I had torque. It'd be the same way. T sub x is the x direction of the torque. T sub y is the y direction of the torque. So we use that little subscript right here to indicate the direction that that particular item is in, okay? So we break things down into their directions, and that's how we indicate it. All right, so let's put that to use. A force of 180 newtons is applied to a structure at an angle of 230 degrees. So step one, always step one, draw picture. Okay, so I'm just going to draw a picture of this. Fubu, if you want to go to the 1031, I can go with you. Your call. I'm almost done with video number 2.
Okay, that's okay.
That's just your call. Okay. Let's see here. Draw a picture. Okay. So that is 0, 90, 180. And so that is, and this is 270. Okay. So if I am doing an angle of 230 degrees, that is from the origin, somewhere right in here. Okay. So that is going to be 230 degrees. And that is 180 newtons. Now here's the thing that always gets people. I'm dropping a vertical that is straight to the x-axis. So some people come off to the side and try to attach to the y-axis. We do not attach to the y-axis, okay? none of the pictures we have drawn have we attached to the y-axis. Okay, it's always to the x. Dropping a vertical always goes to the x. So x is going to be the magnitude, which is 180 times cosine of 230. And y is equal to 180 times sine of 230. Type those in my calculator. So 180 times cosine of 230, that is negative 115.70, and 180 times sine of 230, that is negative 137.89. Okay. Boom. So that's got those done. And now I know the directions. Now, why are they negative? Well, because when you go to the left of the origin, you're negative. And when you go down, you're negative. So negatives always indicate direction. That's really their only point when it comes to anything other than money. They're indicating direction. Okay? And even with money, they indicate debt. But for anything other than money, they are indicating direction. So how many more of these do I have? I got a couple more. All right. So here's the most tricky one. We are coming out of the southwest. So draw a picture. Okay. So let's sketch ourselves a little picture. So we have east, north, west, south, northeast, northwest, southwest, southeast. Okay. Now, for this one right here, it says that I am coming out of the southwest. So I am coming this way. Starting at the origin, I'm going away from the southwest, which pushes me towards the northeast. So this is a 45-degree angle of rotation, and I have 2.5 meters per second squared of acceleration. And then I can just drop a vertical, always towards the x-axis, and that finishes out my vector. And I have a y-coordinate and an x-coordinate. And all I'm going to do is figure out, that color doesn't show up super well, here we go, is find out how much of that is in each direction. So that's going to be 2.5 cosine 45 degrees and 2.5 sine 45 degrees. So that is 1.77, and I think the other one is going to be the same thing. Okay. So I've found how much is in each direction. So this side is 1.77, and this side is also 1.77. And now I have all the parts of my triangle. If I wanted to, I could subtract 45 degrees from 90 and find that top corner if I needed it. So I have everything that I need. Now, why do we bother with finding the two sides of the triangle? It's for one very important but heartfully tragic reason. When you go to do the math, you have to know the x and y directions. It's as simple as that. If we didn't need it to do the math, we would not even bother with finding them. But vector addition, which is what Newton's laws of motion rely upon, can only be done with the x and y components. So where Newton said F equals ma, what he actually said was force, the summation of all of the forces, the addition of all of the forces together as one big unit is equal to the mass of the object times the acceleration of the object. That is what Newton's laws of motion say, not F equals ma, but the net, the summation is equal to MA. And that summation is the catch. So that's what we're getting ready to start talking about. Vector addition. So two trucks are attempting to pull a box. Truck A is pulling with 2,500 pounds of force at an angle of 54 degrees. Truck B is pulling with 800 pounds of force at 350 degrees. What is the net effect? Okay, so step one, brake. Truck A into X and Y. Remember, it's just magnitude times sine and cosine of direction. So X is equal to 2,500 times cosine of 54 degrees. And Y is equal to 2,500 times sine 54 degrees. And so that is going to be 1469.46. And this is going to be 2022.54. Boom. So that gets that first one done. Switch to a different color. Okay, number two. Brake truck B into X and Y. And so that's going to be X equals 800 cosine of 350 and Y is equal to 800 sine 350. Okay, so that's going to be 787.85, and this is going to be negative 138.92. Okay, so there's my two forces that have been broken into their X and Y. Okay, so now I need to add them together. Okay, so let's switch to a different color. Step 3. Find the net effect by adding the two x's together and the two y's together. Okay, so if I add the two x's together, that's 1469.46 plus 787.85. So that is an X direction net force of 2257.31 pounds of force. And now we add the Y's together. That is 2022.54 minus 138.92. And that is 1883.62. And now we've just worked a physics problem. Now we've got one last thing left to talk about. The way our answer is written doesn't make a lot of sense. I want to know how strong the trucks are pulling on the box. That answer of, well, the x direction of the force is 2257.31 pounds and the y direction is 1883.62 pounds. It tells me nothing. I'm like, well, what's the overall effect? I need to know one number. How many pounds does that box feel? I don't need this whole XY crud. I want to know one number. And so that's the last thing we need to talk about, is how to convert our answers back into a magnitude. Okay? And so that's going to be these two formulas right here, magnitude and angle. Now, the angle one changes depending upon what quadrant you're in. So this is very important. I could not find a graphic of this, so I have to hand draw this. If you are in the first quadrant, so that's 0 degrees. If you're over here in quadrant 1, then the formula does not change. Tangent inverse of y over x. So no big deal. If you're in the second quadrant, this is where you have to draw a picture out so you know where you're at. Then it is 180 minus tan inverse of y over x. If you are in the third quadrant, then it's 180 plus tangent inverse of y over x. That's a horrible looking y. Let me zoom in to a better y. There we go. And if you're in the fourth quadrant, it is 360 minus, that's a horrible 0. I've got to get better at these. Tangent inverse of y over x. Okay, now there's one other trick. When you are plugging into these formulas, drop the negatives. These formulas will account for the negatives. So you do not need to add more negatives to the formulas. Okay, so I'm not going to write that down, but that's something that you do want to keep. Actually, I will write that down. When plugging your values into these formulas, do not use negatives. Okay. So you want to keep that in mind. All right, so let's do one of these. An object is being pushed in the x direction with a force of 98 newtons, and the y direction with a force of negative 150. So let's draw a picture. Always start with a picture. Okay, so this is y, and this is x. Okay, so I am in the x direction, positive 98. Always start with x, 98. And now I'm in the y direction, negative 150. So here is my triangle. Okay, so step one is always draw picture. Okay, step two, I'm going to find the magnitude. And I'm going to plug this into the formula, and I am not going to use negatives. Okay, we talked about this. The formula will account for all that stuff. And so the magnitude, which is just a hypotenuse, that's going to be this, come on, square root of 98 squared plus 150 squared. That is 179.18. Okay, so 179.18. All right, and now to finish this up, all I need to do is find the angle. Now this is in quadrant 4. So that's going to be 360 minus tangent inverse of y, which is 150, over x, which is 98. Notice again, I did not put the negatives in there. 360 minus tangent inverse of 150 divided by 98. And that gives me a rotation of 303.16 degrees. So that is the direction. Boom. So I have found the final condensed perfect answer for this physics problem. All right, I'm going to stop right there because I've got to get some food and some other stuff in, and it's an early Sunday morning. But we will be back with some more videos a little bit later on, so go do your homework. All right, talk to you guys later.